Hi everyone, you're welcome back to my channel. In this video, I'm going to discuss briefly the basic laws of indices. Let's start by understanding what indices is all about. Indices is simply exponent or powers in algebra. So these are basically the two terms used in place of indices in algebra. Now the word exponent can be defined as how many times a number is used in a multiplication. Now, let's say, for instance, we have 8 to the power of 2. 8 is regarded as the base. 8 is a base. And 2 is regarded as exponent or power. Can also be regarded as index. Now, the word index is simply the singular form of indices, the same as indices, but in singular form, it is index. So, and that's why the word index is used. So when we're referring to just a single number in the singular form, its index. Now, let's have a look at some of the basic laws of indices. Now, we have basically five key laws of indices, starting from the first law that says that when you're multiplying the same base with different indices, multiplication becomes addition. So we add the powers. In this case, a to the power of m times a to the power of n is equal to a to the power of m plus n. Now for the second law, which says when you're dividing the same base with different indices, here it's a to the power of m divided by a to the power of n. Division becomes subtraction. So we have to subtract the powers by writing a to the power of m minus n. For the third law, when you raise a power to another power, in the case of m is raised to another power n, so we have to multiply the powers or the indices. Multiplying m by n gives us a to the power of mn. Now, for the fourth law, any value raised to the power of 0 is equal to 1. So as we can see here, a to the power of 0 is equal to 1 on the condition that a is not equal to 0. In other words, a has to be greater than 0. Now for the fifth law involves negative indices, where a number written with a negative power can be equal to 1 over the number with a positive power. In other words, we're referring to the reciprocal. The reciprocal of a to the power of negative n can be written as 1 over a to the power of n. Now, here are some of the key laws of indices. So we are now going to apply them in different situations. Now, by looking at some examples, example 1, simplify 4t to the power of 4 times 3t to the power of 3. Now, the first step is to identify the coefficient of t to the power of 4, which is 4, and the coefficient of t to the power of 3 as 3. So first, I'm going to multiply the coefficient together. 4 times 3 is equal to 12. And then we've got t to the power of 4 times t to the power of 3. Now, applying the first law of indices that says multiplying a common base with different indices. So the common base is t. And the different indices here, in this case, we have to add the indices, which is 4 plus 3. Now, 12t to the power of 4 plus 3 becomes 12t to the power of 7. So you add 4 to 3 to give 7. So the answer to example 1 is 12t to the power of 7. Now the next example, simplify 64u to the power of 36 raised to the power of 5 over 6. Now, in this case, we have to distribute the power 5 over 6 with every single term inside the bracket. So I'm going to distribute 5 over 6 with every single term inside the bracket. So in this can be written as 64 raised to the power of 5 over 6 times u to the power of 36, now raised to the power of 5 over 6. Now we can further simplify this expression by writing 64 in index form. To further simplify, we need to write 64 in index form. And to write 64 in the index form, we can apply the factor tree or use the factor tree. In this case, I have 64. So I'm going to look for the number of 2's that multiply to give 64. So starting with 2, 2 times 32 gives 64. Now for 32, it's 2 times 16. 2 times 16 equal to 32. 2 times 8 gives 16. For 8, it's going to be 2 times 4. Finally, for 4, it's 2 times 2. Now, I'm going to count the number of 2's that multiply to give 64. Now we have 2 times 2, 2 times 2, times 2, times 2, times 2, then times 2. So we've got how many 2's? We can count 1, 2, 3, 4, 5, 6. So it's going to be 2 to the power of 6. Here we have 2 to the power of 6. Now raised to the power of 5 over 6. 5 over 6. Now times. Now in this case, for the second term, we have u to the power of 36 raised to the power of 6. According to the third law of indices, a power raised to another power, we have to multiply the powers or multiply the indices. So when multiplying 36 by 5 over 6, we can actually cancel out. 6 goes into 36, and that is 6. So with this, we have 6 u to the power of 6 raised to the power of 5. We can also multiply the power 6 by 5 to give 30, and that gives us u to the power of 30. Now for the first term here, 2 to the power of 6 raised to the power of 5 over 6, we can also cancel out the 6. 6 goes into 6, and this is 1. So we're left with 2 to the power of 5 times u to the power of 30. So we're going to write this as 2 to the power of 5 u to the power of 30. Now, the final answer to this question is we can still further simplify 2 to the power of 5 because 2 to the power of 5 gives us 32. 2 times 2 times 2 times 2 times 2 is equal to 32. So the final answer to example 2 will be 32 u to the power of 30. So with this, we've come to the end of the video. If you find the topic interesting, you can go ahead and click the like, share, and subscribe button. Thank you.